Let's roll. So we've added fractions. We've subtracted fractions. Now, whenever you add or subtract fractions, the first thing you got to think is, I must have a common denominator. That thought has to be in your mind. If I don't have one, I will make one. Once I have a common denominator, I add the numerators and put them over the common denominator. Adding fractions. Second operation, multiplying fractions. Multiplying fractions, always look to RBUM, reduce before I multiply. And once I've reduced, then I'll do top times top, bottom times bottom. That's it. Lastly, dividing. Okay, so we addition, multiplication, not a whole lot there. Now, the last operation is division. So we have an example here of a couple fractions being multiplied, right? We're looking right here. You don't need to circle it. I'm trying to focus your attention. So you have the fraction A over B divided by, you see the division symbol, C over D. And you guys learned in elementary school or whatever to do what? What did you learn? How do you do this division problem? You guys all had it. How do you do this division problem? What do you do? Only 2 people remember how to divide fractions? What do you have to do? 3, 4? Rest of you don't remember? It's okay, put your hands down. It's fine. I'm just curious. How many you don't remember at all what to do? I'm just curious. Okay. Go ahead and put your hands down. So hopefully this will be a refresher. So who wants to take a shot at it? Colby, you want to take a shot?
You would flip C and D, or C over D.
You not only do you flip C and D, and I agree, and I'm going to put the green D on top and the red C on the bottom. Colby, there's one other thing you do besides flipping the second one. What do you have to do to the division symbol? You turn it into a multiplication symbol. Correct. So you invert the divisor. You give the reciprocal of the divisor. You flip the divisor. The second fraction is the divisor and multiply. So hey, dividing fractions is like multiplying. So in words, what are your thoughts? Usually something like invert. That means flip the second fraction. That means the reciprocal of the second fraction. That means take the bottom of the second one, put it on the top, and the top of the second, put it on the bottom. You invert the divisor, the second one, and multiply, right? That's what should be in your brain when you come to dividing fractions. And in addition to that, once you get to the multiplication step, you'll want to RBUM. Because once you're there, it's just a multiplication problem, yes? This right here, you don't need to box it in, is a multiplication problem. So once you're at the point when you're ready to multiply, you're going to RBUM, reduce before you multiply, then top times top, bottom times bottom. So dividing is a lot like multiplying, except you take the second fraction and you flip it upside down, change the division symbol to a multiplication symbol. Now, that's a method. No one would ever come up with that on their own. It's a shortcut. It's a way of getting the answer. Why do you get the answer that way? And that's what I want to try to show you here in just a couple minutes. So let's take a look at that situation. Why does this rule, let me cover this up first. Why does this rule, right, have the same thing, A over B divided by C over D? Why does this rule work? How does this even come to be? All right. First off, I have to convince you, do you agree that the blue box that I just boxed in is the same as this right here? Do you agree that they are one and the same? Right, I took the A over B fraction and I divided it by the C over D fraction. Are you okay with that? Does it make sense? Okay. So that's how we start. Now, here's the problem. We have a fraction divided by a fraction. And the question is, how can I get the denominator How can I get the bottom to be 1? If I can get the bottom to be 1, I no longer have a fraction divided by a fraction. So, I'm going to multiply C over D by something so that I end up with 1. So that's the thought. What can I multiply C over D by to get 1? Now, let me make a box here so I can get you guys to understand what I'm saying. Let me add some color to it, solid fill. What color will it be? It's always blue. I don't know why default is always blue, but it is. All right, so let me grab this, pull it over here just to cover that up. Look, don't worry about the top. I could care less what the top is. I don't care about the top right now. All I care about is a C over D. What can I multiply a C over D by to get it to be 1? That's what I'm after. Want it to be 1. Edward?
D over C.
Exactly right. If I multiply it by a D on the top and a C on the bottom, do you agree that the bottom is now going to be 1? Right? Because we can reduce that and it all reduces down to 1. Now we have to remember, well, I really am doing a problem here. And if I just multiply the bottom by D over C, I have changed the value of the fraction. So what can I do to keep from changing the value? What can I do to make this a legal operation? I just can't multiply the bottom by a D over C. So what else do I need to do to make it legal? Anybody? Let me give you an analogy. Okay, everybody look up here on the right-hand side of the screen. Kristen. So if I had something like this, if I had, don't write this, 3/5 plus 7/15. What would you do to be able to add these fractions? Colby?
Multiply 3 over 5 times 3 over 3.
Okay, so hopefully this is the way I taught you. I would multiply this bottom by a 3 to get it to be a 15, right? And then I would say what words? What words do I usually say right now? Say them. I usually say, whatever you do to the bottom, do the same thing to the top, right? Agreed? Because what's 3 divided by 3? 1, and if you multiply anything by 1, you don't change its value. Changing the form, but I'm not changing the value. Okay, so with all that in mind, now let's go back to our question. If I multiply the bottom by D over C, what do I have to do to keep this to be legal? Juliana? Exactly. I have to do the same thing to the top. I have to multiply the top, and use your color here, by D over C. Whatever you do to the bottom, do the same thing to the top. Now, what happens on our bottom? C divided by C divides out. D divided by D divides out. Do you agree?
Yes.
And all we're left with is the top. You can box it in right now. Do you agree? That's all that we're left with? Okay. You don't need to do this in your notes, but isn't this that? That's why the rule works. The rule is a shortcut to doing it this way. That's all it is. It's a shortcut to doing really what the division is. Dividing top and bottom by the inverting of the divisor. It's a shortcut. Because the bottom is going to be 1, we can just disregard it and only worry about the top. It's a shortcut to doing this. So that's why the rule works. That's what's involved. Now, by the way, there are times when we'll have to do this principle right here. Or it's easier to use that principle, and you'll see it when we get to it. But a lot of times students just like to think, hey, invert and multiply. Invert and multiply. Oh, I was supposed to do it down below. I forgot, so we'll just scribble that out. Don't worry about it. Not a big deal. Sometimes I think of it one way, and then I think of it another. Okay, so let's do a couple of these problems. So that's a little bit of the why. And look, honestly, if you don't completely understand the why, can you still do division? What if you don't completely understand what I just showed you? Does that mean you can't do any dividing of fractions? Well, no, you still know invert the second one and multiply, all right? So let's go ahead and do that. We're going to have the 3/5 is going to stay, right? Do you flip the first one? No. You flip the second one. And by the way, I am looking for this rule step right here. So show me the flipping, or I'll flip out. You don't want me flipping out. You know, people get old, they flip out easy, so make sure you show the rule step on these. And by the way, I'm looking right now to reduce. It's on this rule step that I will reduce. Do you agree there is none? Okay, but I'm looking. So we can go to our final answer. We all know 3 times 7 is 21. We all know 5 times 4 is 20. And the answer is 21 over 20. Piece of cake. No sweat. And division, look, if you can multiply, you should be able to divide. You just got to remember to invert the second fraction, change the division symbol to a multiplication sign. Okay, so go ahead and do number 3. I'm going to pause the video and let you do number 3. Okay, so hopefully you started that way. Now I helped you out. I said R-bum at the rule step, so hopefully you're all thinking about it. -6 is a -2 times 3. 25 is a 5 times 5. It's going to allow me to divide out my 3's and divide out my 5's. And once you're done with that, there's not a whole lot left. What have we got? 2/5? -2/5? That's it, right? So, look, again, don't waste your time in multiplying it, then unmultiply it to reduce it, right? R-bum. R-bum. Reduce before you multiply. Reduce before you multiply. Reduce before you multiply. Oh, no. Now we have a fraction and a whole number. Surely we'll have no earthly idea how to do this one. Okay, just set up the rule step. Be careful. And I just want to make sure that you know what to do on this one. Go ahead and do the rule step. Should take you a second. For some reason, this bothers students, but it's a pretty easy problem once you understand the situation. Christina, you got it? Just do the rule step. Got it already? So hopefully you thought, hey, the front is a -3/7, and the back is what? What's the back fraction?
5.
Right? It's just 1/5, because that's just a 5/1, and surely we're not going to miss a problem like that, right? That's easy. So where do we end up? There's no reducing, but I'm looking. -3/35 if you can do your times tables, right? So how many got the 1/5 and you were thinking, okay, good, right? Those shouldn't give us any trouble, cause us any concern. What about if the whole number's in the front? Is that going to drive us crazy? A piece of cake. Just put it over 1. So 18/1. Flip or invert the second one, 5/8. Don't be a bum. Go ahead and finish it. I'll finish it. We'll see if we end up at the same place. Nine times 5 is 45, and we got a 4 on the bottom. 45/4. Do you concur? All right. 9 times 5 is 45, and 1 times 4 is 4. And we didn't change it to a mixed number because the problem didn't have 2 mixed numbers to begin with, right? Just leave it as an improper fraction and roll on. Let's do another. Oh my, a mixed number and a fraction. We're shaking in our boots. All right, go ahead and work through it. I'm going to work through it as well. If you're stuck, look up at the screen. If you're good, keep going. See if you can get the correct answer. Don't be a bum. Your answer going to be positive or negative?
Negative.
There you go again. Always so negative. only one mixed number, so let's leave it improper, right? Don't need to. It's not required if only one of them was a mixed number. How many got negative 34 thoids? Beautiful. Beautiful. All right. So we converted the mixed number to a fraction, invert the second, and multiply in arbum. 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 Okay. So what if the mixed number comes second? See what you can do with that. Again, you can look up at the screen. I'm going to work mine as you work yours and see if you're thinking correctly. Answer going to be positive or negative? Negative. What a negative class, I'll tell you. So negative 1050 foists, do you agree? You concur? So again, just be careful there. Change that mixed number to a fraction, and then you're going to have to invert it, right? Got to change it first, then invert it. Now, how many got that one right? All right, bunch of brainiacs, right? So what's the deal with fractions? They're easy. They're easy. Why do you have fractional phobia? They're easy. Like that someone mouthed, I don't. Very good, you shouldn't. They're easy. Easy. Uh-oh, two mixed numbers. See what you can do with that, Mon. Two mixed numbers. Again, you work it, I'll work it at the same time, and I'll be in Scotland before you. You know that song, right? You take the high road, and I'll take the low road. And I'll be in Scotland for you. For me and my true love will always something something. And the something 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 of the something. All right, yeah. Too many somethings. Oh, reducing? 4 times 6 is 24. Well, at least we don't have to change it to a mixed number. Because it's proper. It's a proper fraction, right? Negative again. Negative 64 95ths. Do you agree?
Yes.
Because 5 times 20 is 100, and I'm 1 5 short, so that'd be 95, right? Let's do the last problema, the Grande Finale. All right, so I'm going to pause. Why don't you try the Grande Finale? So everybody got 5, right?
Yeah.
All right, let me get your attention quiet, please. Folks, my words, when I speak, you need to focus and listen. If I have to keep telling you more than once to get your attention, then it becomes a problem, and I will do things that will cause you to want to listen to my first direction, okay? So if you want to talk and stuff, you know, at times I'll let you, but when I call you to basically attention, you have to come to attention, which means you may have to stop in the middle of your sentence and not finish the little thing you were saying, right? And if you'll do that, then you'll keep some liberties. And if not, then I'll have to pull those liberties away. All right, so we dealt with the parentheses, right? And finally got it to its fraction. Order of operations, deal with parentheses first. Then I inverted that second fraction and did the multiplication the second time, right? So just order of operations, parentheses had to come first, so I had to deal with it first. If you violate the order of operations, you will get the problem wrong. So you just need to follow the order of operations, and away you go. And voila, you are there. How many got that right? I know a bunch of you did. Awesome, right? All right, so let me set up the rest of the week. So I want you to do the assigned homework tonight, which is on your sheet there, right? Listen up, just stop, pause, don't go grabbing stuff. Then we will work a couple worksheets tomorrow that are going to deal with adding, subtracting, multiplying, dividing fractions. We'll work some of the worksheets in class. Whatever you don't get done in class will be homework, and we might finish a good amount of those worksheets in class. There are 2 of them. We will quiz on Wednesday. We will review on Thursday, and we'll have a test on Friday over adding, subtracting, multiplying, dividing fractions. It's so important, and really, my goal for each of you is to get at least a 90 on that test on Friday. You want it to where hopefully the only thing you're missing is making a mistake. You know what you're doing. You make a mistake here, or you make a little mistake there. That'll affect your grade. But other than that, we should be able to know how to add, subtract, multiply, or divide fractions for sure by Friday. Again, there's not a whole lot to it. Adding fractions, make sure they have a common denominator. If they don't, get one. Get a common denominator. Then add the numerators, put them over the common denominator. Multiplying fractions. Before I multiply, I'm going to reduce, and then it's top times top, bottom times bottom. Dividing fractions. I'm going to invert or flip the second fraction, change division to multiplication. And again, before I multiply, I'll look to reduce, and then it's top times top, bottom times bottom. That was like 4 things. And that's all fractions. That's it. We just took care of everything. Adding, subtracting, multiplying, dividing. They're really easy. They really are. But those thoughts need to be in your head. All right, so I'll give you the rest of the class for this homework, and then we'll review tomorrow and Thursday, quiz on Wednesday, test on Friday.